Hello, everyone. Good afternoon. Dear authors and invited guests, welcome to the technical session 10C. My name is Siddhi Auti and I'll be your moderator for today's session. On the behalf of Global Knowledge International Conference on Smart Trends in Computing and Communication, SMARTCOM 2025. The ninth edition of the conference is being held in a hybrid mode. The physical event was conducted on 29th January and the virtual event was conducted yesterday and today. I hope you all will enjoy this interactive and knowledgeable session. In this session, in total, we will be having 10 presentations. Each presenter will be given a time span of 10 minutes. After 7 minutes, I will be raising a gentle reminder. 2 minutes are kept for question and answers. Also, there is another request to all the participants that you stay connected with us till the closing remarks. And if you face any issues or queries, you can write it to me in the chat box. Now, just before we start the session, I would like to introduce you all to today's session chair, Dr. Archana Chaudhary.
Should I switch on my camera? Not needed, no?
Ma'am, it's not necessary, whatever is convenient for you.
Okay, thank you.
Okay, Dr. Archana Chaudhary is an assistant professor at Vishwakarma Institute of Technology. She has over 20 years of experience, including 4 years in industry and more than 15 years in academia. She has published several research papers in international journals and conferences. She is an IEEE member. Her research interests include signal and image processing, IoT, control systems, artificial intelligence, and machine learning. Welcome, ma'am, to today's session. Now we'll proceed to the first presenter, and the paper title is Automatic Generation of Executive Summaries for Online Meetings Using NLP, a review. This paper would be presented by Sujit Kumar Banda from Chaitanya Bharati Institute of Technology. I request Sujit Kumar to please start with your presentation. I think Sujit has not joined yet, but we will proceed to the next presenters since we have a time constraint. So the next presenter is Govind Murari. Let me just check if these participants have joined. Okay, so Rutu just joined, so I think we can start with this paper. The effectiveness of artificial intelligence in stock market prediction. This paper would be presented
Hello.
by Rutuj Garudwal. Hello.
Yes, ma'am. I'm present, ma'am. Hello. Yes, ma'am.
Sir, can you start with your presentation?
Yes, ma'am. Can I share my
Okay.
presentation?
Yes, you will be able to share your presentation.
Okay. Good afternoon, everyone. I am Rutuj Barudwale from Varda, DMHR in city of Savangi Mege. And my topic now, my paper name is Effectiveness of Artificial Intelligence in Stock Market Prediction. Okay. Executive summary. This study looks at how artificial intelligence can predict stock market. The research used two approaches, technical analysis and fundamental analysis. In technical analysis, we look out for past stock prices, means you know that we are do research for stock. We are predicting stock from that past data of a stock market, and that fundamental analysis means we are taking a public opinion from social media like Instagram or Telegram channels. Introduction of the study. The stock market is complex with many factors affecting stock prices. Predicting stock movements is a big challenge because the stock prices are fluctuating by seconds. This study use AI, including machine learning (ML), to predict stock market, past prices, data, and social media opinion. So AI is predicting the stock market prices by using the past few years of data, and that they are predicting the price market. Objectives of the study: to understand how well AI models can predict stock prices. using machine learning. Compare the two methods of analysis: technical, price trend, fundamental, social media opinion. We are taking two trends like technical and social media opinions to test which AI models like support vector machines, networks, linear regression error, and LSTM work with stock prediction. Review of literature. Many studies have shown that AI can help predict the stock market, but no model is perfect. In my research, I predict that 76% of the AI rule means is perfect, not AI not confirm 100% of prediction of stock market. Only 76% of stock market prediction is correct accurate. There are two theories. Efficient market hypothesis suggests that stock prices already reflected all available information, making predictions difficult. Adaptive market hypothesis suggests there are times when stock prices are insufficient and prediction can work. Scope and limitation of the study. This study focus on using AI models to predict stock prices, past data, technical and social media sentiment as fundamental. We are taking our focus on the AI models to predict stock prices, like taking a few few past year data and taking some social media sentiments like from Instagram and Twitter channels. Influencers are giving their advices on the social media, like platform like Instagram and there's limits. Some data, especially from social media, was missing or incorrect. No model has consistently predicted stock prices perfectly because research hypothesis. AI models can predict stock market changes effectively. Social media sentiments has an impact on predicting stock market. Regression models will give better results than classification models when predicting the exact stock prices. Data analysis and evaluation. Data use historical stock prices from Yahoo Finance, tweets from social media about companies. Data cleaning. The data was cleaned to remove error and make it machine learning. Machine learning models used classification models like SVM predict if a stock market will go up or down. Regression model predicts exact stock prices. Windings. Technical analysis, linear regression was better than LSTMC for prediction, predicting Apple. Fundamental analysis, the SVM model performed best with an accuracy of 76%, predicting stock prices based on social media and less accurate than. Conclusion: AI tools can help, but they don't always beat the stock market. AI can help predict stock prices, but no model is always accurate. AI only help you to for doing our means AI is not 100% accurate. It is only help for if you have knowledge. Use our AI. Only 75% of percentage of accuracy is there in AI. Combine both technical and fundamental analysis might help to prediction. More research is needed to make AI tools more reliable. Suggestions. Future research. Try combining technical and fundamental method into one better accuracy. Both both combined technical and fundamental means you can take data from AI. AI is doing take few years of data of stock market and give you any conclusion, and take some fundamentals data from social media platforms. Ask to influencer or CA. They are also helping in giving the advice. Improve sentiment analysis. Improve the way we analyze social media data prediction more accurate. Real world testing. Test these AI models in live trading to see how they are markets. This all is my references.
Thank you, sir, for your presentation. If there aren't any questions, then we can go to the next presenter.
Yes, go ahead.
So the next paper title is Integrating AI with IoT, a review of applications, challenges, and future directions. And this paper would be presented by Edidiong A.K. Papio from Tatta Mega Institute of Higher Education and Research, India. I request Edidiong sir to present your paper.
Yeah, good afternoon to everyone. Is my voice audible, please?
Yes, your voice is audible.
Okay, please give me some time while I share my screen.
Yes, sure.
Yeah, is my slide visible to everybody, please? Yeah, so good afternoon, everyone. My name is Edidion Opabio, and I'll be presenting on the paper titled Integrating AI with IoT, a review of its applications, challenges, and future directions. I myself and my co-author, Professor Supriya Naragba. And so these are the table of contents, the introduction to the references, and then let's go to a brief introduction. So AI and IoT, they are becoming more prevalent across several industries, which is because of the recent advancements in technology as well as connectivity, where IoT is a collection of technologies that allow items to establish with connections between one another over the internet. And also we can see AI, which involves the simulation of human method into computers so they can function effectively. And also in summary, we can see that IoT is a network of interconnected physical devices that lack the need for human to computer as well as human to human interaction. And then, so they have IoT devices, they're having sensors, processing power, and other technologies which are helping them exchange data with other systems over the internet or other communication networks. So we'll be looking at literature review where some authors have talked about some of these. They have given their own ideas also. Like, for example, the second author talked about an innovative AI gazer system that works depending on the pattern of utilization as well as energy conservation. And they have employed KNN algorithms here. So they have combined AI as well as IoT sensors as well as machine learning algorithms to get this particular AI gazer model. And then also we'll be looking at this other one where they used crop recommendation and disease prediction, where they have used image analysis to do that, as well as combine it to get crop recommendation, as well as check a particular disease affecting the plant in the soil. And also the last person also have talked about how AI could enhance human machine interactions in the future. And then we'll look at some applications here. Number one is agriculture. In agriculture, as I mentioned before, where we saw a crop recommendation system. And so here it's used to manage agricultural products within collected real-time data. And also we have one, a pit machine with diagnosis pests as well as soil defects using computer vision as well as deep learning algorithms as well. And then they process data that are captured by sensors. And also Plantics, which is another deep learning algorithm, which identify potential defects as well as nutrients deficiencies in the soil. And also we can see in the smart cities where we have traffic management, the energy efficiency, as well as urban planning. And then in vehicles, autonomous vehicles, where we can see sensor data processing, where AI is being used, as well as decision making, where we have some self-driving cars that are all over the internet today. Also in healthcare, we can see how IoT integration with AI can make it easier for healthcare professionals to respond to a patient state, which makes the intervention quicker, which also in turn enhances chronic related illness management. And then there are some challenges here, especially related to AI and then the IoT, which is over the internet. Number one is data privacy and security. So we can see that IoT is creating vast volumes of data, and they are collecting data, most especially personal information, of which if it's not used wisely, it could fall into the wrong hands, which could cause harm to a particular user. Then also we see data quality and management. You see the data in different form of images, in form of text, and which of course it's very difficult to manage them, heterogeneous data from different places. It's very difficult to manage them. You can see like in different formats, then PNG, docx, XLX, XLSX, and others. And also we can see the ethical and bias concerns when we see that AI, there are some ethical and biases concerns, like for example, AI bias where it's feeding data, wrong data pertaining to a particular race, to a particular person. So which doesn't make the decision transparent. And then in the future, we hope to see some things like Edge AI. We hope to see AI enhanced IoT ecosystems and the next generation connectivity, like such as 5G networks, as well as 6G in future. We hope to see them how they can enable the integration of AI and IoT to make life easier for we humans. So in conclusion, we say that the combination of this is a very powerful concept, which will massively impact on the way that new ideas are brought to the market, as well as on the human experience. And also this integration also is creating new opportunities in the cities, smart cities, healthcare, industrial automation, as well as different other fields. And also we need continual advancements to contribute to shaping a connected, efficient, as well as a sustainable future, even when we have challenges such as data privacy and as well as also security problems. So these are some of the sources I got my information from, and thank you.
Thank you, sir, for your presentation. Are there any questions or should I proceed further?
Yeah, please go ahead.
Okay. So the next presenter is Rhythm Berry from Alliance University, but I guess she is not joined yet. So we will proceed to the next presenters first. The next paper title is Sign Language Recognition and Caption Generation, a Review. And this paper would be presented by Chidrapura Harini from Chaitanya Bharati Institute of Technology. I request ma'am to please start your presentation.
Hi, can you please allow to share my screen?
Yes, sure, ma'am. I've stopped sharing my screen.
Yeah. Good afternoon, everyone. I'm Harni from Chaitanya Bharati Institute of Technology. Our paper title is Sign Language Recognition and Caption Generation, a Review. These are the contents. Coming to the introduction, sign language is not just the language that we speak every day. It's a visual language that happens with the hand gestures. There are like many sign language, like American Sign Language, British Sign Language. There are over 1.8 million people in India, like they can't hear. This is for the people who can't hear or hard of hearing. Yeah, this builds the gaps between the normal people and the hard of hearing people. Coming to the literature survey of first paper is conversion of sign language video to text and speech. In this, the authors took the video and then they have used the CNN, especially the Inception V3 model, to extract the spatial features. These are then given to the RNN, especially the LSTM, to extract the temporal features. They have also used Google text to speech to convert this text to speech. Coming to the second paper, video captioning and sign language interpreting. Here the authors trained many American Sign Language videos. Here they have divided the model into two. One is video encoder and the other is caption generator. They have used 3D convolutions, pooling layers, LSTMs, and achieved an accuracy of 85%. Coming to the next paper, efficient gesture recognition for the assistance of visually impaired people using multi-headed neural networks. Here, they've used multi-head neural networks, which has fully connected layers, and there are many layers. Especially the DarkNet 53 is used here to process the images and extracting the features. And here the accuracy is over 89%, more than all. Coming to the fourth paper, YouTube ASL, a large-scale open domain American Sign Language English parallel corpus. Here, they have used the American Sign Language videos. They've used the media pipe to extract the key points on hands or faces. And then these are given to a transformer called T5 transformer to convert this into captions or English text. They have used the blue score and got it as 12.39. Yeah, coming to the fifth paper, sign language recognition system applied to deaf mute medical consultation. Here, the authors created their own data set. They have consulted like 10 people and they have taken different gestures. They have used MobileNet YOLO V3 model. Here, the YOLO V3 model is the object recognition model. It is used for gesture recognition, and MobileNet is used to reduce the cost. Here, the accuracy is more than all the papers, like it's up to 90%. Coming to the sixth paper, sign language interpreting system using recursive neural networks. Here, instead of taking a recorded video, they have taken the live video and used the media pipe and open pose to extract the key points on the hands. They have created the data set of like 600 video clips. They have tested with using 4 variants of CNN, like LSTM, bidirectional LSTM, and GRU. Yeah. Coming to the seventh paper, video-based sign language recognition via ResNet and LSTM. Here they have taken the Argentinian sign language dataset and they have done augmentation like to avoid overfitting. Here the ResNet is used to extract the spatial features and LSTM is used to extract the temporal features. Finally, the fully connected layer is used and have achieved an accuracy of 86%. Coming to the eighth paper, automated 3D sign language caption generation for video. Here the speech is converted into the sign language and they have integrated this in the classrooms in schools and they have achieved an accuracy of up to 70%. Coming to the ninth paper, continuous sign language recognition towards large vocabulary, statistical recognition systems handling multiple signers. Here they have tested for different signs, not only one sign as we saw earlier. Like they have detected the hand movements, facial expressions. They have done 2 tests like in the laboratory and also in the real time. It showed 30% more improvement. Coming to the final paper, video captioning based on sign language using YOLO V8 model. Here they have used the YOLO V8 model to extract the spatial features, which is then passed through the spell checker to detect the final temporal features and then captions are generated. Yeah. Now, by combining all these papers, we thought of doing a project. As we see in YouTube, we have captions for all the YouTube videos. So we thought of taking a sign language video as input and then generating the captions for the sign language video, so that normal people will also be able to understand the sign language. So this is what our objective is. And in this, we have identified many challenges that there are very limited data sets. And also there are very gestures that are very variable. And the complexity is also huge. And integrating this in real time is also like very difficult. Yeah. Next, my co-author Veena will continue further presentation.
Hello, I'm Saivina Kurella, the co-author of Sign Language Recognition and Caption Generation. So basically, as you all have seen, we have gone through many papers, like about 10 papers. And finally, we have our own methodology, what we have figured out from those papers. So there are basically 2 steps. One is sign language recognition, that is detection, and then generating the captions for that. So first, sign language detection is done by taking a video input and then coming to the data processing. So basically, in data processing, what happens is we will be identifying the spatial and temporal features. Temporal features is nothing but it's related to the time lapse of from which minute to which minute is the sign taking place and all. So based on that we can identify. And spatial features is identifying the key points as discussed by my co-author. And based on those temporal and spatial features, then caption generation comes into the picture. And next slide. So yeah, caption generation, our goal is basically to detect that sign and then generate the English translations also, like as you can see for the YouTube videos. So that is basically done with the help of RNNs, which will help us to identify the features. And then using different attention mechanisms, the gestures will be identified. And finally, the outcome will be along with the sign language video, there will be the captions generated so that it will be readable by all other people who are not physically challenged. So moving on. Yeah, so finally coming to the conclusion. So this is what we have done. Like, it's a new idea, as you can see. Like, we do have like for the live videos, we have many projects like related to them, where you can get the caption for a single sign. But our take is to take a video as an input and then generate the signs to that. Yeah, thank you. So these are the
Thank you, ma'am,
references.
for your presentation. Now we'll proceed to the next presenter. The paper title is Automatic Generation of Executive Summaries for Online Meetings Using NLP, a Review. This paper will be presented by Sujit Kumar Banda and his co-authors. I think Mohammad Arbaz Ahmed sir is present in the meeting and he will be presenting on his behalf.
Yeah,
Okay, sir, you may start with your presentation. I'll stop sharing my screen now.
just give me a minute to present the screen.
Sure, sir.
My screen visible?
Yes, sir.
Okay. Good afternoon, everyone. I'm Mohammad Arbaz, co-author of the paper. It is an honor to present our research study titled Automated Generation of Executive Summaries for Meetings Using NLP. So these are the contents of our paper. Coming to the introduction, uh, our research studies in today's digital world, online meetings have become an essential part of professional and academic life. However, the managing and recalling information from these meetings presents significant challenges. So our research proposes an automated system that uses NLP to generate concise executive summaries of these meetings. Uh, why are we why are the online meetings important nowadays? As we know that the platforms like Google Meet, Zoom, and Microsoft Teams have revolutionized communication, making remote work and global collaboration seamless. And these meetings generate a massive amount of information, but without a proper documentation. So challenges in the meeting are like volume of information are there. Meetings can be lengthy, often lasting hour and more, and manually taking notes or reviewing entire recordings is time consuming and inefficient. So dependence on the manual note taking is also there. Different people may interpret meeting discussions differently, but manual notes may be incomplete, inconsistent. So our proposed solution is using NLP. It works in such a way the system records a transcribed meeting audio. It processes the transcript using NLP techniques to extract the key points. The result is a concise, structured summary that highlights the main discussion points. So the benefits of this approach are like it saves times, improves accuracy, and enhances the productivity. It can be used in the education, research, and healthcare sector also in corporate worlds. So coming to the motivation. Now, the key factor of driving the research are increasing dependencies on the online meetings. With the rise of remote work and virtual collaboration, the professionals rely on platforms like Google Meet, Zoom, and Microsoft Teams. And managing multiple meetings daily makes it difficult to track discussions effectively. And the information overload and cognitive load. Meetings often last 30 minutes to 2 hours, making it time consuming to extract key insights. And professionals have limited time to revisit recordings or read through the long transcript. Even the time constraints for professionals, senior executive managers and employees often lack in the time to take detailed notes. So manually summarizing meetings requires additional efforts, leading to inefficient and lost information. Uh, like And we also need the automated summarization nowadays. The AI-powered summarization ensures that accurate and structured documentation without the human bias is there. And it also standardizes the meeting summaries across organizations. And it also improves the productivity by saving times for professionals. How our solution enhances productivity? It helps teams stay aligned with the summarization and discuss it in easy to write format. So, in objectives, we have three objectives. The first one is to develop an AI-powered system for automatic meetings summarization. Our system will capture and summarize key points and action items from online meetings audio. This ensures that the professional can quickly access important insights. And second one is to build a user-friendly Chrome extension for real-time summarization. And user will receive real-time transcription and summarization. And third one is to ensure high accuracy and relevance using NLP techniques. It also optimizes the system performance for scalability and efficiency. Coming to the literature survey, we understand the NLP techniques. We understood how it being used, which we also research on the gaps, the methodology, and key observations were taken from the three, six research papers. The first research paper, the meeting summarizer using NLP, which the methodology used over here is TF-IDF and text rank, and the observation was the efficient for extractive summary. The research gap was it lacks coherence if key points are scattered across the non-contiguous sentences. In the second paper, automatic meetings, minutes generation using natural language process, it uses BART, T5, and summarization pipelines. uh, the observation here was the high accuracy was generated. Research gap was that it might suffer from noise and transcription errors in speech to text conversation. The third paper is the a ranking based language model for extractive summarization. It uses n-gram probability based ranking. It showed good performance on the structured data sets, but it limited accuracy for diverse data sets. It lacks deeper content and understanding. And the fourth paper, the stepwise summarization approach, it involved breakdown summarization and multiple steps. More controlled and transparent summaries was observed, but it lacks in more computationally intensive and requires fine tuning for different text types. Yeah, in the fifth paper, it uses the Whisper AI for transcription, followed by the Pegasus and BART.
Hello. Sir, sorry for the interruption, but we are past the presentation time. Can you please get to the conclusion?
Okay, okay. In the result analysis, it was observed that the F1 score precision and recall comparison, the Pegasus was used, BART was used, and meeting summarize was used. The meeting summarizer model has the least F1 score, and the Pegasus showed the highest F1 score. And in the when we compared the result analysis of the Google Pegasus BART, and the BART performance was well Rouge 2 and lags behind Google Pegasus in Rouge 1 and Rouge L. In conclusion, we use the abstractive and abstractive summarization, which rewrites the content in concise and readable summary. The system identifies highlights, the key decisions, summarizes important solutions, and action was to capture assigned tasks and responsibility, and the deadlines were given to the each user specific, which helped to stay organized and no critical information is lost in that. So the base algorithm we use are TF-IDF, text rank, and for abstractive, the BART and T5 was used. Thank you.
Thank you, sir, for your presentation. Now we'll move on to the next presenter. So the next paper is Integrated Approaches for Secure and Predictive Management of Electronic Health Records, a review. And this paper will be presented by Satvik Taviti from Chaitanya Bharati Institute of Technology, India. I request Satvik sir to start with your presentation.
Yeah, just a second. I'll share my screen. Yeah. Am I audible and the screen is visible?
Yes.
Yeah. Good morning, everyone. I am Satvik, the author of this paper, and my paper is Integrated Approaches for Secure and Predictive Management of Electronic Health Records, a review. My co-authors are Shreyashi Kurlagunda and Nandikanti Sri Gayatri. We are from Chaitanya Bharati Institute of Technology. So, beginning with, electronic health records are digital versions of patient medical history, including diagnosis, treatments, and test results. So basically, these electronic health records provides the interoperability across healthcare platforms, we know, which can revolutionize the industry by improving data accessibility, care coordination, and treatment accuracy. But as we know, the patient's medical history is highly sensitive and it requires very strict measures to prevent breaches and unauthorized access. So this major drawback of EHR systems has, mainly slowed down the widespread adoption of fully digital EHR systems. So beyond EHR systems storing only the patient data, we can also leverage deep learning models for predictive healthcare, and analyzing the patient data history to predict any healthcare diseases that can be recognized further. So basically, EHRs can be achieved through various approaches. The major three of them are blockchain-based security, attribute-based encryption, and access control techniques. So coming to blockchain-based security models, we primarily focus on data integrity, privacy, and efficient access control. So the major approaches and considerations for a blockchain-based EHR is smart contracts. Basically, smart contracts automates access control and consent management. They also enhance patient control over their health records. Next is using a decentralized framework. Basically, it builds trust by eliminating central authority reliance and secures information exchange among many healthcare stakeholders. We also use Hyperledger Fabric that provides secure, traceable access with unique IDs and ensure immutability and data traceability. The major drawbacks this model has is transaction lag and scalability issues, which we have been seeing from past EHRs, and lack of standardization as well, where the interoperability becomes an issue, and high infrastructure cost, which many of the stakeholders cannot afford. Next, we come to the attribute-based encryption security models. Basically, AB is used for EHR by only allowing authorized people to access specific health information based on the role or attribute. For say, a doctor can access the patient medical history, whereas the other pharmacists and all cannot access them. Only they can access the prescriptions. So in this, various techniques involve ciphertext policy, key policy attribute-based instruction, policy hiding, attribute-based encryption, and multi-authority. The major thing in all of them are the access that is determined by the one of the thing is policies, and other thing is the attributes, and next is the policy which is hidden in the ciphertext to prevent unauthorized access, and the last one is providing decentralized control over access. The major challenges here we face are encryption and decryption, which obviously takes time, and this slows down the process of EHR. So in basically EHR, we use them, to speed up the process, but this obviously is a drawback. Next is field level encryption and unauthorized access uses infer data through policies, revocation issues, key management complexities. The final one we come is the access control techniques. Access control techniques basically define how users and systems interact with resources, ensuring that only authorized individuals can access or modify sensitive data. As you have previously read, patient health data is very sensitive, and to be able to modify, you need to have certain authority. So this access control techniques implement that. So for that, we have role-based access control. There are roles like doctors, nurse, or admin who can access patient records on based on their roles, and if they have the authorization, they can modify them as well. Next is attribute-based access control. Basically, this offers more flexibility than the role-based by granting access based on attributes such as characteristics like cardiologist or nurse. Next is time of access, like he can be given access for a specific period of time. And next is location. The major challenges are lack of flexibility, role explosion. Basically, the role of the user is exposed. Like if he's a doctor, since he's a doctor, he'll be able to access that. Next is limited granularity. Challenges faced in attribute-based are complex policy issues and scalability. So, as we have seen the various approaches to implement electronic health records, one thing we can do, to include all of them are deep learning techniques for predictive management. Basically, EHR prediction enhances by including this deep learning methods. When we have complex data sets, they can identify patterns in medical history, lab records, and clinical notes. So it improves accuracy in predicting diseases, disease risk, patient outcomes, and personalized treatments, offering insights beyond traditional methods. So the some of the approaches are RNNs that are used for predicting patient outcomes, then CNN, LSTM, and logistic regression. The challenges of deep learning are it requires basically high quality data set. It is a complex model, and privacy concerns obviously. Next is computational resources and overheating. So coming to the conclusion, blockchain attribute-based encryption, deep learning, and access control methods have the potential to be game changers in electronic health records, offering secure, efficient, and personalized healthcare management. While there are still challenges to overcome, such as scalability and resource requirement, addressing these issues carefully can unlock their full benefits, transforming how medical data is managed across healthcare systems. Thank you. Any questions?
No questions.
Yeah. So,
Thank you, sir, for your presentation. Now we'll proceed
Yeah.
to the next presenter. So the next paper title is Psychoacustic Wellness Unveiling the Efficacy of Vedic Chants and Music on Alleviating Depression. And this paper would be presented by Dhanush Rajan from PES University, India.
Am I audible?
Yes, sir, you're audible.
Yes, sure. Right.
You can start with your presentation.
Yes. Is the screen visible?
Yes.
So, good afternoon, everyone. I'm very glad to present my conference paper in SMARTCOM. Myself, Dhanush Rajan, and my paper title is Psychoacoustic Wellness, Unveiling the Efficacy of Vedic Chants and Music on Alleviating Depression. My co-authors are Shreya, Dhanush Karthike, and Ashwati. So, these are the contents of this presentation. So, moving forward, introduction and motivation. So, we know that depression is a widespread mental health issue in millions of people globally, which is characterized by diminished brain activity and altered EEG signals. We know that ancient Vedic chants are known for their calming and meditative properties, and they are shown for potential therapeutic benefits, improving mental health, behavior, and lifestyle. So, how about bridging these timeless Vedic chants into our modern healthcare of depression? This study explores the profound therapeutic potential. And also for the motivation is that regular chanting of the holy names fosters mental clarity, eliminates negative habits, alleviates stress and depression, and enhancing inner well-being, led to a more harmonious and fulfilling life. This is spoken by one of the great spiritual leaders. So it was a motivation. So coming to the summary of literature, we took so many papers and we found that depression, a multi-phase mental health disorder, is associated with reduced alpha wave activity in the frontal cortex, indicating diminished relaxation, and altered beta wave activity, impacting focus on logical thinking. And EEG has proven to be a valuable tool for analyzing all these health related issues. Just by analyzing EEG, we'll be able to figure it out what kind of medical well-being has to be given. And also music therapy and the group musics have been shown positive effects in alleviating depression, anxiety, and also chanting and breath work practice, including Om chanting and Hare Krishna Maha Mantra, have demonstrated significant potential in reducing stress, anxiety, and depression. And also a holistic diagnostic approach, integrating clinical, physiological, and EEG-based philosophical measurements is essential for accurate understanding and diagnosing and depression. So also we found that literature gaps are that the previous authors, they have taken only certain chants like Om and Hare Krishna Maha Mantra, but they did not consider much of various kind of chant categories. And also they've not taken into consideration of this alpha and beta power, which are mainly we can understand how depression works there. and also lack valuable insight of EEG analysis. So many people, they did not think about the EEG to a well extent such that they can be analyzed. So coming to the objectives is that to extract and analyze EEG features such as alpha power and beta power and symmetry for identifying makers of this mild depressive disorder MDD, and also to classify these paging chants into different categories such that we can understand it properly based on their male frequency substral coefficients, which is MFCC coefficient values. And also we need to combine these Vedic charts into EEG features such that we can increase this alpha and beta power, and we can show that actually the depression has been healed further. So this is the methodology, this is the block diagram of methodology. We have taken a depressed MDD patient's EEG signal and we have done the pre-processing, and we have extracted the features, which is alpha wave power and beta wave power, which lies in the respective frequencies. We have used filtering techniques such as Butterworth filter and low pass filter. Ultimately, will be if there is increase in alpha and beta power, we will be concluding that the depression has been healed to a quite extent. So for the data part, we have taken data as open and eyes closed condition of this MDD, major depressive disorder patients. And also, as said, we have classified into certain categories such as neutral, calming, aggressive, rejuvenating based on their MFCC coefficients and their emotion felt while hearing. So, and feature extraction part, as said, we need to take into consider alpha power, beta power, and symmetry. And these alpha waves lies in the category of 8 to 13 hertz, and beta waves 13 to 30 hertz. And also we used certain tools such as Librosa, which is used to find the MFCC coefficients of those chants, and also pi EDF values. This pi EDF is used for the medical signals which can be stored in that for EDF format. Also using EEG lab toolbox, we properly understood the visualization part of these signals. So moving forward, pre-processing has been done as said using the filters using the EEG toolbox. And also we classified based on their MFCC coefficient values. We have taken the first coefficient values because it shows the energy of those chants. So we got these values. Moving forward, we have simulated the EEG signals, and we also for the visualizing part we used EEG lab toolbox, and we used this HAMD score. If the score is beyond 0 to 7, it is normal. So they have segregated properly such that whether it's mild or moderate or severe. So for our paper, we have taken only this mild depression case. Moving forward. So before the given of these chants, we can see that alpha and beta power were too less in the power of 10 to the power minus 10. So we gave these proper chants to those depressed signals, and we found out that there is increase in alpha power and beta power, which indicates that there is significant improvement in their EEG signals. Concludes that there is cure of depression. So we found that calming chants and rejuvenating chants are performing better than other chants. So we used the visualization tool EEG lab, where we can see that we provide a 30 seconds of clip to those EEG signals, and we found that there's slightly improvement in the alpha power and beta power. We can see those visualization diagrams there. And also we conducted a survey with age group of 20 to 70 people of total 20 with the age of 20 to 70, and we found that they gave a rating of the chants so that we can understand it, how they experience it. Because this is not a medical paper, this is a signal processing paper. We are trying to prove that chanting and the Vedic chants, they cure depression. And also conclusion is that Vedic chants demonstrate therapeutic efficacy, particularly in improving neural activity in mild disorder depressed patients, and significant increase in alpha and beta power validates the hypothesis of chants aiding in emotional regulation and stress relief. And also this research, it bridges ancient tradition with modern neuroscience, providing a promising avenue of alternative mental health therapies. Future directions. So coming to future directions, real-time testing. It can be these, what we have tried to prove theoretically can be actually done practically by using a real tester maybe. And also we can expand the data set. We can see in the HAMD data set, there are major and minor. We can combine all this and we can check for a better understanding. And also we can add subgenres also and additional chants. We have used 16 chants and categorized into 4 categories. So we can also increase that. And also we need to understand the long-term effects because we used only 30 seconds of clip. So if you used even more, there can be improvement in depression. And also there can be a comparison of these Vedic chants curing and also with the therapeutic music which they be used also. That also comparison also can be done. Process going on. And these are the references which we used. So any questions? Also, thank you.
Thank you, sir, for your presentation. Are there any questions?
No, good presentation. Yes, go ahead. No questions.
Now, before proceeding to the closing remarks, I would like to call out the names of the absent people one last time. If any of the co-authors from these paper titles are present, please let me know and continue with your presentation. So the first is Prashant Vats from Manipal University of Jaipur. And the paper title is Time Series Analysis for Stock Market Prediction, Techniques, Challenges and Future Directions. Next is Rhythm Berry from Alliance University, Optimizing Plant Disease Detection with a novel deep ensemble framework. And lastly, Govind Murari Upadhyay from Manipal University, Jaipur, with the paper title Development of an Energy Efficient Deep Learning Framework for Intrusion Detection in IoT Environments. Okay, so I think these people are not present in the meet, so we shall proceed to the closing remarks.
Okay. So I congratulate the authors for the presentation. And I have in this track we had lot of review papers. So the authors have done extensive study of the topics and presented the literature survey. Few of the papers were on some methodology, so they were also very good, especially the last paper. And the review papers also consisted, they were not only review papers, but actually rigorous analysis of the review papers was also conducted. So I congratulate all the authors and the conference. So thank you.
Thank you, ma'am, for your kind words. I sincerely thank our authors for their excellent presentations and contributions in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on the behalf of whole team, thank you for the support during the 9th version and all the previous 8 versions of the conference. We will be happy to see you all in the 10th version in 2026. All the presenters would be getting their digital certificates through email within 2 working days. Further, all the papers have already been forwarded to the Springer. The publication will be live within 6 months. Kindly cooperate with the team of SMARTCOM 2025. I also thank our session chair, Dr. Archana Chaudhary, for chairing this session.
Yes, thank you.
A token of appreciation to the chair on the behalf of Team SmartCom 2025. Thank you, ma'am, for your valuable presence. Now, just before ending this meeting, I request all of the participants to turn on your cameras so that I can take a quick snapshot of today's virtual conference. Okay, so I've taken the snapshot. Thank you, everybody. This was a great session. We can end this call now.